Video, we'll be discussing about Mathematics Paper 4, Mechanics Sem 1, 2017 February March, variant is 429709. Particle of mass 0.4 kg is projected with a speed of 12 meter per second. That means the value of u, that is the initial speed, is 12 meter per second of the line of the greatest slope of a smooth plane. So as the plane is smooth, that means there is no effect of friction. Thus, we can eliminate the part mu r for this question. Of the line of the greatest slope of the plane, inclined at an angle of 30 degree to the horizontal. So it is at an angle of 30 degree to the horizontal. Find the initial kinetic energy of the particle. So initial kinetic energy is equal to half into mass into speed square. That is the initial speed. So we find the initial kinetic energy, that is 28.8 joules. Use the energy method to find the distance the particle moves up the plane before coming to instantaneous rest. Instantaneous rest, that means velocity is 0. We need to find the distance when velocity becomes 0. So we know that the initial value of kinetic energy and final kinetic energy, since final velocity is 0, so final kinetic energy would also be 0. So final EK would also be 0. So the change in kinetic energy would be 28.8 joules. And since the plane is smooth, that means initial kinetic energy is equal to final gravitational potential energy, since there is no effect of friction. So initial kinetic energy is gravitational potential energy, that is mass into gravitational field strength into vertical height. So we find the value of vertical height. Since we know the value of vertical height and the value of angle, so sine theta or sine angle is equal to opposite by hypotenuse. So we equate this to find the value of distance d, that is the hypotenuse, as 14.4 meter. In question number 2, a particle of mass 1.6 kg is suspended in equilibrium. At equilibrium, the resultant force is 0. So particle P is in equilibrium by two inextensible strings attached to the point A and B. The string makes an angle of 20 degree and 40 degree respectively with the horizontal. Find the tension in the two strings. So we need to find the tension, that is T1, and the value of T2. So we are given the mass of the particle, that means the weight is acting particle downwards, that is 1.6 g. And for T1 and T2, we need to find the horizontal and the vertical component of these forces, that is T1 cos 20, T2 cos 40, T1 sin 20 and T2 sin 40, and their respective direction. Then we equate each of this horizontal component to each other and the vertical component to each other to find these two expressions, and then we substitute equation 1 in equation 2 to find the value of T2, that is 17.4 Newton, and then put the value of T2 in expression 1 to find the value of T1, that is 14.2 Newton. Question number 3, a particle of mass 0.6 kg, that is its weight is 0.6 g, that is vertically downwards on a rough plane. That means frictional force is acting on the particle, that is mu r, is inclined at an angle of 21 degree to the horizontal. So the angle is 21 degree. The particle is kept in equilibrium. That means the overall component of these forces is 0 by a force of magnitude p Newton acting parallel to the line of the greatest slope of the plane. So for this question, we have to consider that p is always acting upwards. That means whatever would be changed, p would remain the same, that is acting upwards. The coefficient of friction between the particle and the plane is 0.3. So we have also given that the value of coefficient, that is the value of mu, is 0.3, so that the least possible value of p is 0.470. So we need to find the least possible value of p, that is 0.470, carried to 3 segment figure, and find the greatest possible value of p. So for these values of p, least value and for the greater value, we have to consider two scenarios. For the first part, that is the object is moving upwards. As the object is moving upwards, so as friction is always acting in the opposite direction of motion, so for the object moving upwards, friction would act downwards, and for the object moving downwards, friction would act upwards. And for these two scenarios, we have to find the two different values of P. So for the first value, that is the object moving upwards, and therefore friction acting downwards, and the downward component of weight. So we equate this to find the value of P, that is 3.83 Newton. Then for the second scenario, the object is moving downwards, hence friction is acting upwards. Thus P plus mu r is equal to downward component of weight. So we equate this to find the value of P, that is 0.470. This is the least value, and for the greatest value, P is 3.83 Newton. Correct to three significant figures. So in question number 4, a car of mass 900 kg is moving on a straight horizontal road ABCD. So his car is moving on the road A, B, C and D. There is a constant resistance of magnitude 800 Newton in the section AB and BC. So between the section A to B and from B to C, there is a constant resistive force of 800 Newton and a constant resistive force of magnitude R newtons in the section CD. So between the section CD, there is a constant resistive force of magnitude R. The power of the car's engine is kept constant at 36 kilowatt. So power is kept constant at 36 kilowatt. So in question number 1, the car moves from A to B at a constant speed. Since speed is constant, therefore driving force is equal to resistive force. And from A to B, speed is constant in 120 seconds. Find the speed of the car. So we have to find the constant speed and the distance AB. So we need to find the distance between A to B. So for constant speed, driving force is equal to resistive force. Driving force is equal to power divided by velocity. Power is 36,000 watts divided by velocity is equal to resistive force, that is 800 newtons. So we equate this to find the velocity, and distance would be s, that is ut plus half at square, and since it is moving at a constant speed, so the value of a is 0, thus ut or vt. So the value of v is 45 and the value of time is 120. We calculate the value of distance, that is 5400 meter. The car's engine is switched off at B. So at point B, you have to notice that the car's engine is switched off. That means there is no driving force at B. The distance BC is 400 meter. So we know that the length of BC is 400 meter. Find the speed of the car at C. So for the speed of the car at C, first of all, we have to use the expression v square minus u square is equal to 2as, and since we need to find the value of v, we know that u is constant, that is 45 meter, and the value of distance is given here is 450 meter. So for this section we already know these values, but we need to find the value of a, since the object is decelerating as there is no driving force since engine is switched off. So resistive force is equal to mass into acceleration. We equate this to find the value of acceleration, that is negative 8 by 9. So we put the value of acceleration in the expression and find the velocity, that is 35 meter per second. The car comes to rest at D. So at D, the speed of the car is 0. The distance AD is given. Find the deceleration of the car and the value of R. So for the deceleration of the car, between part C and D, the deceleration would be, since we know that the final velocity is 0 and the velocity at this instant that we have calculated earlier, that the velocity at C is 35 meter per second. So velocity at C is 35 meter per second, the velocity at D is 0 meter per second. So v square minus u square is equal to 2as, and we can use this expression to find the value of a, but the distance CD would be distance AD, that is the total distance, minus distance AB and BC, that is given here. The distance AB is 5400 meter, and the distance BC, that is given earlier in this question, that is 450 meter. So we subtract this to find the distance CD as given 787.5 meter. Since we know the value of distance and the value of v square and the u square, so we equate this expression to find the acceleration, that is negative 7 by 9. So the deceleration would be just 7 by 9, and it is positive. Then for this deceleration we need to find the value of r, and since r is the resistive force that is acting between C and part D, so for the part C to D, resistive force is equal to mass into acceleration, and since resistive force is acting causes it to decelerate, so it would be negative resistive force is equal to mass into acceleration. So acceleration is also negative and resistive force is also negative, so these two cancels both each other out, and since speed is 0, since the driving force is 0, therefore resistive force is equal to mass into acceleration. So we equate this to find the resistive force as 700 Newton. In question number 5, a particle P moves in a straight line starting from point O and comes to rest at t is equal to 35 seconds. That means at t is equal to 35, v is 0. At time t seconds after leaving O, the velocity v meter per second of the particle is given by. So here we have given three expressions for the velocity at the given time intervals. Show that the values of A and B are 49 and negative 0.04. So first of all, as we can see that both A and B are in the third equation, and to find these values of A and B, we know that the final time is 35 and the final velocity at time t is equal to 35 is 0, that is here. And we know that the initial value of time, that is 15, and for this value of time we need to find the value of velocity. And since we also see that here is also 15 seconds time, that means the velocity at this point is equal to the velocity at this point. So velocity at B, or second expression, when time t is equal to 15 is 40 meters per second. So at time t is equal to 15, the velocity is 40 meters per second, and at time t is equal to 35, velocity is 0 meter per second. So we use these two values to find the expression 1 and expression 2. Then solve it simultaneously. Find the value of A, that is 49, and the value of B, that is negative 0.04. Then in part B, or second part, sketch the velocity time graph. So for this velocity time graph, we have to draw it in three different phases: first phase, second phase, and third phase, for three different equations. So for the first equation, as we can see that this is a quadratic equation, and since this quadratic equation is positive, thus we have a minimum point. So for this minimum point, first of all we need to find each of the values of v and the value of t. Since we know the value of t, so for each values of t, we put these values in the given expressions and find each values of v for each time interval. As we know that the value of v and t, now we can draw the graph easily. So as I was saying that it has a minimum point for expression 1, since it is positive, and at time t is equal to 0, velocity is 0, so velocity is 0, and time t is equal to 5, velocity is 20. Thus we have to consider only this section of this graph, that is this region. Then we can see that v is equal to 2t plus 10. Since it is a straight line graph, that means we would have a straight line between time t is equal to 15, 5 to time t is equal to 15. for the velocity that is 20 and 40 meter per second. So for the velocity between 20 and 40 meter per second, then for the third equation, that is v is equal to a plus bt square, that is the third equation is here, v is equal to a plus bt square, that is v is minus 0.04 t square plus 49. So for this expression, as we can see that this is also a quadratic equation, but we have a negative t square. That means we have a maximum point. And for the positive t square, we would have a minimum point. But for this negative t square, we have a maximum point. So thus, according to this graph, as t square is negative, thus we would have a maximum point. And since we have a maximum point, so this point would slightly look like this. Sorry, my bad. This point would not look like this. This point would look like this section, that is sloping downwards. So it would just slope downwards. It would just slope downwards like this. So sloping downwards. So as t square is negative, thus we would have a maximum point. So it would move like this. Move like this. Okay. Then part 3 of question number 5. Find the total distance traveled by P during the 35 seconds. That is, we need to find the area under this velocity time graph. So area under this velocity time graph would be the equation, as we have 3 equations. So we have to integrate this equation in order to find the distance and in range of the given time. That is, for the first expression, the time limit would be 5 to 0, for the second 5 to 15 to 5, and for the third 35 to 15. Between these time intervals, we have to integrate these expressions separately and find the value of distance or the area under the graph and sum this up to find a value of distance, that is 787 meters. In question number 6, two particles of mass 1.2 kg and 0.8 kg are connected by light inextinguishable strings pass over a fixed smooth pulley. The particles hang vertically. The system is released from rest. That means they are initially at rest. With both the particles are 0.64 meter above the floor. In the subsequent motion, 0.8 kg particle does not reach the pulley. That means 0.8 kg particle would move up since it does not reach the pulley, and 1.2 kg particle would move down. So find the acceleration of the particle, that is 2 meter per second square, and find the tension in the string, that is T. So for 0.8 kg particle, since it is moving up, so T minus its downward component of weight, that is 0.8 g, is equal to its mass into acceleration. And for 1.2 kg particle, since it is moving down, so its downward component minus tension is equal to mass into acceleration. Then we solve these two expressions simultaneously to find the value of acceleration, that is 2 meter per second square, and the tension, that is 9.6 Newton. Find the total distance traveled by 0.8 kg particle during the first second after the particles are released. So during the first second after the particles are released, so as we can see that after the particles are released, 1.2 kg particle would move down at a distance of 0.64 meter, and 0.8 kg particle would move up. So for this distance, we need to find the time when 1.2 kg particle reaches the ground. So S, that is 0.64, is equal to ut plus half at square. Since u is 0 as the initial at rest, so half at square. So we find the value of t, that is 0.8 seconds. Then we know the value of t, and when 1.2 kg particle reaches the ground, just before it reaches the ground, we need to find its speed, and also this speed is also the same speed as when 0.8 kg particle reaches this same distance, that is 0.64 meter above. So speed when 1.2 kg particle reaches the ground would be v square minus u square, since u is 0, is equal to 2 as, where a is the 2 meter per second that we have calculated earlier, and distance is 0.64 meter. So we calculate this and find the velocity at which 1.2 kg particle reaches the ground is 1.6 meter per second. That means when 1.2 kg particle reaches the ground, 0.8 kg particle would also have a speed of 1.6 meter per second. And as 0.8 kg particle has some speed, that means it would move up until its speed, that is final speed, reaches to 0. So final speed, it would move up until its final speed is 0. So for the 0 final speed and the initial speed, that is 1.6 meter per second, when 1.2 kg particle reaches the ground, we know that the final speed and the initial speed, and we know that as the 1.2 kg particle reaches the ground, that means the string becomes slack, or there is no tension in the string. Thus 0.8 kg particle would move freely with an acceleration of minus 10 meter per second square. So acceleration would be minus 10 meter per second, final velocity would be 0, initial velocity at which 1.2 kg particle reaches the ground and 0.8 kg particle moves up is 1.6 meter per second, and final velocity for which 0.8 kg particle reaches its maximum height is 0. We equate this to find the distance that 0.8 kg particle travels until it reaches its maximum height. So this distance is extra distance covered by 0.8 kg particle until it reaches its maximum height. So for this maximum height, we know that the initial speed is 1.6 meter per second and acceleration is 10. So we use the equation s is equal to ut plus half at square and find the value of t when 0.8 kg particle reaches its maximum height, that is 0.16 meter per second, 0.16 second, since it is time. So if we think or see that when 1.2 kg particle reaches the ground, it takes 0.8 second, and when 1.2 kg particle reaches the ground, it takes 0.8 seconds, and when maximum speed is reached by 0.8 kg particle, it has a time of 0.16. That means in total we have covered 0.8 plus 0.16 second, and in total we need to cover 1 second. Thus in extra, that is t3, thus we need to cover to make a total of 1 second is 0.04 second. So for this time interval of 0.04 second, we know that 0.8 kg particle is at momentary rest, that means u is 0, that means it is at its maximum height, So at this maximum height, u is 0, that means at maximum height final velocity is 0, thus we consider the final velocity is u is 0, and acceleration is 10 meter per second square. Since it is at its maximum height, so now it would move down, and since it would move down, thus acceleration is 10 meter per second square. Thus we need to find the distance it covers when time t is 0.04 seconds. So distance would be s is equal to ut plus half at square. We equate this and find the distance, that is 8 into 10 to the power negative 3 meter. Thus in total the distance that is covered is 0.64, 0.128 and 8 into 10 to the power negative 3 meter. Thus in total we have a distance of 0.776 meter. Again, this 0.64 meter is when 1.2 kg particle reaches the ground. This 0.128 meter is when 0.8 kg particle reaches its maximum height, and this 8.3 meter is when 0.8 kg particle moves from its maximum height to downwards until it covers approximately 1 second. So this is our total distance it covers for a time period of 1 second.